Now, just like we saw with our pairs of parallel lines cut by a transversal and finding the angle measures for corresponding angles and alternate interior and exterior angles, when we have lines three lines that intersect, we can form a triangle. And we can find out some properties and some relationships between all of the angles formed by those three intersecting lines. So, first of all, we have one relationship between all the angles inside our triangle. So these intersecting lines create this lovely triangle. And here we're calling these angles A, B, and C. And those are the interior angles of a triangle. And one thing that we know about the interior angles of every triangle is that they sum to 180 degrees. So that means the measure of angle A plus the measure of angle B plus the measure of angle C is going to be 180 degrees. So if we know two of those angles, we can find the third angle, because we know that they have to add up to 180 degrees. Always, always for triangles. Something that we notice now about the exterior angles of a triangle. So these are angles on the outside of the triangle, and it says here, or their opposites. So what we mean by that is we have D here or the one over here on this side, which we could call D prime. And remember, what's the relationship between D and D prime? If you remember from a previous video, they are vertical angles. So they should be congruent to each other. Same thing with E and E prime here. F and F prime. They are congruent because of vertical angles. But another thing that we want to look at is we could have angle D, E, and F, and if we sum them together, the measure of angle D plus the measure of angle E plus the measure of angle F, all together should sum up to 360 degrees. So some interesting properties for lines that intersect to form, three lines that intersect to form a triangle.